Today we have a Sony SLFH400 Super Betamax. This one was given to me. Actually, I got this from that estate. So this is my machine. It's not working properly. We're going to tear this one down and see what's causing a problem, see if we can get it working. Today I have a Sony Betamax. I know some people will pronounce it differently. Some people pronounce it Betamax. Others will pronounce it Betamax because, hey, when you've got two vowels together, you get normally the long sound. So Betamax may be the actual way to pronounce it. But I call it Betamax. This is a Super Beta Hi-Fi SLFH400. This was one of the first of the Super Beta models, and this replaced the SLFH400. Essentially the same unit as an SLFH400, but with Super Beta capability. And to understand the difference between standard Beta and Super Beta, what they did was when hi-fi sound was added, unlike what was done now, I'm speaking NTSC. The PAL version of Beta was different, or Beta Hi-Fi was different than the NTSC. And the PAL version was actually a year behind the NTSC version. And briefly to explain the difference as I take this thing apart, because this one is not working. Because PAL operates at 50 fields or 25 frames per second, and NTSC operates at 60 fields or 30 frames per second, the head drum is synchronized to the video frames or video fields. 1/2 of a revolution per field. So basically 1 full revolution per 2 fields or 1 frame. So the video head spins at 30 revolutions per second, 1800 RPM on the NTSC versions, because each rotation of the video head corresponds to 1 full video frame or 2 fields. So your video head here contains 2 heads, A and B. And as the head drum rotates, the A head will record the A field, and when it's finishing writing its field, the B head is in position to begin writing the B field. 30 revolutions per second. PAL, on the other hand, it's 25 revolutions per second. Therefore, on NTSC, the head drum revolves at 1800 revolutions per minute, and on PAL, it's 1500. Now, why is this important? Well, your relative writing speed is determined by how fast the head scanner spins. You've got a fixed length of tape that wraps the scanner, and the faster the scanner spins, the faster the relative tape to head speed. No different than on audio recorders such as a reel-to-reel. If you turn the tape speed up, you get improved frequency response than the slower tape speed. The PAL systems, and this applies to all analog video formats, whether it's Beta or VHS or 8mm, does not apply to DV. I'll get to that in a minute. But the analog formats, it does. The head and DV, the head drum runs at the same speed regardless what video format it's being recorded, whether it's PAL or whether it's NTSC. The head drum runs at the same speed, but on analog the speed is different. Because of this, the PAL system with the lower head speed has a lower writing speed, and your frequency that gets recorded is determined by the writing speed. When they developed Beta Hi-Fi, what they did was they took a portion, about 400 kilohertz of bandwidth, off of the lower sideband between the chroma and the luminance signal. And this has been gone over on, if you watched my video on the Sony, the Beta Hi-Fi training, but I can draw it out here pretty simple. So if this is your frequency, this is 0. My pen's not writing, it's cold in here. All the racket you hear, I've got 2 electric heaters running in here right now. 2 made in Canada electric heaters, I should add. Because it's, today it's about -8 outside. And when I turned the heaters on about an hour ago, it was about -2 in the shop. And I've got it up to about 7 degrees now after an hour. But it's a little bit chilly today. So you've got your, on beta, you've got your color, which is recorded around 600, well actually it is recorded at 688 kilohertz. So your chroma is recorded in this frequency band at 688 kilohertz, centered at 688 kilohertz. And one thing I'm not going to do is I'm not going to go into the exact frequency, because working off memory, this is something I learned almost 40 years ago, so I might be a little bit off on the frequencies. So I'm not going to even go into the frequencies, because someone out there is going to troll me on the frequencies if I'm off. But on Betamax you had 1.2 megahertz of bandwidth. I think it was 3.6 to 4.8, I believe was the bandwidth. So you had your carrier, and your lower sideband came out. This is for the luminance, and it rolled off like that, and it was basically 3.6 to 4.8 megahertz. This was your carrier centered, and your lower sideband extended down to pretty much where the color cut off, like down like this. This was the standard mono beta. VHS was 3.4 to 4.4 megahertz. I forget. I think it was 3.6 to 4.8, because this was standard beta. And when they put the Beta Hi-Fi in, what they did is they rolled off the lower sideband a little sooner, and then they had room to put the 4 AFM carriers recorded by the same heads for the hi-fi audio. But what this resulted was that because they had stolen some of the lower sideband, this is the lower sideband and this is the upper sideband. The upper sideband's frequency is limited by the tape itself and the characteristics of the heads, because once you go beyond a certain point, just like with analog audio recording, once you get beyond what the tape can saturate, the frequency rolls off. Better tape, better heads would result in a higher frequency, and this is exactly what Super Beta did. But the reason that they developed Super Beta was because by shifting up the carrier, they actually shifted it up from 4.8, I think it was to 5.2 for Super Beta, or for Beta Hi-Fi. So they shifted to make space, they shifted up the carrier a bit. I think it was to 5.2. This was regular beta, but when they went to Beta Hi-Fi, this went to 5.2. It went to 3.8 to 5.2. I think that's what it went to. I'm probably wrong. I'd have to go look at the training manuals, which I've got, but I'm not going to dig them out. If you look at the Sony, my presentation I put up a number of years ago, the 3-hour presentation of Super Beta that was done by Omar Morier of Sony when I was in the business, he explains it in detail, what was done and why it was done. But Beta Hi-Fi initially stole some of the bandwidth that was available. and they shifted up the carrier slightly to make some room, but they still lost some of the lower sideband. So Super Beta comes along. Super Beta, same thing, but now we're going to shift the carrier up higher. That's what they did for Super. So your 688 is still your chroma. Your 4 carriers for the AFM is still in the same place, which is in the 1.5 to 1.7 megahertz range. The lower sideband now is able to start relatively soon and extends up a little bit further, and it went up to the high end was 5.2 megahertz, and they still had 1.2, so it went from 4.0 to 5.2 megahertz for your luminance carrier. This was Super Beta. So what they did was they shifted the carrier up. Before it was down at 4.8. They shifted it up 400 kilohertz to regain the bandwidth that they lost when they put the AFM carriers in. And that way they restored the picture quality to what Super Beta had originally had, or what Betamax originally had, for what they lost on Super Beta. And the machines all have a switch on the front of them, a manual switch right here. Super Beta on and off. And the reason they had that switch was on playback, that also affected the bandwidth. If your playback circuit was expecting frequencies upwards to 5.2 megahertz, and they were actually ending at 4.8, which is where the original Betamax was, you'd end up with some streaks and so forth in the picture because there was no information there, just noise. It would degrade the picture. Now, the Betamax system was expanded once again with Beta 1, where they took it from 5.2 and they extended it all the way out to 6.0 megahertz. And this was called Super High Band. So it's still, the low end still was at 4 megahertz, but it now went all the way to 6 megahertz. And that's the Beta 1 SHB. Beta 1S is not. Beta 1S is the same. It's still the 5.2, or was it 5.4? Why am I thinking 5.2? It was 5.2. When they went to Beta Hi-Fi, they went up 400 kilohertz to free up some space. But so they went from 4.8, they went to 5.2, and then they bumped it up to 5.4. I think that was what they did. Again, it's all in the training manuals, which I don't have one kicking in front of me. So if you're going to troll me on the frequencies that I'm quoting here, don't, because I'll delete your comments. If you start to troll me saying, I looked it up and this is that, I'm telling you right now, don't bother. Don't waste your time, because the frequencies I'm quoting here are something I remember from 40 years ago. It's nothing that we ever worried about in the field. I'm just trying to explain it so you understand what they did on Beta. Was they shifted the carrier up slightly for Beta Hi-Fi, but in the process they lost some of the lower sideband, and it degraded the picture ever so slightly. Not much, but it still did degrade the picture slightly. So then they brought out Super Beta to bring that bandwidth back and add a bit more to increase the picture quality a little bit. And then the Super High Band, they pulled all the stops out and increased the band, or increased the frequency, the upper end of the carrier, to 6 megahertz. Anyway, this only applies to the NTSC machines, because on the PAL machines they didn't have this. The PAL machines rolled off, I think it was around 3.6. The carrier was lower on PAL, and they didn't have, because the head drum is spinning so much slower, 1500 RPM versus 1800, they didn't have the available bandwidth that they could shift the carrier up. So what the PAL system did was they had to do the same thing that VHS did, and that was go to deep layer recording with a second pair of heads that recorded at a much different angle. So on Betamax they use azimuth recording, and the heads are plus and minus 7 degrees. One head is tilted 7 degrees negative of being perpendicular to the tape, and the other head is plus 7 degrees. Minus 7 degrees, plus 7 degrees. VHS was minus 6 on one and plus 6 on the other. The audio heads, though, were at like 30 degrees offset. So if the plus 7 head would have a minus 30 degree offset for its pair, for its audio pair, and the minus 7 head would have a plus 30 degree offset, or in the case of VHS, 6 degrees on the video head. But that gave a 36 degree difference in the angle that the signal was recorded to the tape. The audio was recorded first on a leading pair of heads, and then the video was recorded over top of it, which would erase some of the audio signal, but there was enough there to be recovered by the audio head on playback. That was employed on the PAL Betamax, just like on VHS Hi-Fi. But the NTSC, which is what this one is, it's just 2 heads, and the video heads record both the hi-fi sound and the video at the same time. Clear as mud, right? Watch the presentation that Omar Morier from Sony did when I did that training course back in, I think it was 1986 or 87 or whatever, whenever the SLHF400 hit the stores, which was the same time that this one hit the stores, because they had 3 models that were released at the same time. They had the SLHF400, which is this one. They had the SLHF600, which was the next step up, and then they had the SLHF900. The difference between the 3 machines was this was a 2-head machine. The SLHF600 was a 3-head machine, so it could do slow motion and it could do still frame, because it had a double azimuth head that had an A and a B field on it, and then of course the other head, which was just an A or B field, I think, or was it an A? Doesn't matter. Point is, it could play back the same field from both heads for still frame and for slow motion. The SLHF900 was their first quasi-editing deck. It had 4 heads, so 2 double azimuth heads, so it could do slow motion in forward and reverse and freeze frame, and it had editing capabilities, but it did not have flying erase heads. And I actually took one of my SLHF1000s, the head drum seized. The rotary transformer fell apart and it seized up. So I actually transplanted a 4-head drum from an SLHF900 and put it into an SLHF1000. And I've still got the good head disc. I could, at some point, if the heads wear out on the drum, I'll transplant the head, because the rotary transformer for the flying erase heads was actually on top, and the rotary transformer for the video heads was below the drum. So I keep my old SLHF1000 head drum just for the day that the heads wear out, and I need to change them again, because parts for these things, of course, is very hard to come by. Anyway, I've rambled on about this one enough. Let's just see what this one's doing. I just wanted to kind of explain to those rookies that don't know how the beta system works, how it differs from VHS. So this is a 711 chassis, 711B chassis, I believe this one was called, and it uses it's a 4-motor system, sorry. 1 drum motor, a capstan motor. It has a reel motor down here with a pendulum gear for both fast forward and rewind and play. You can see the motor down below that gear. And it has a combination loading motor using a planetary gear set, and there's a solenoid. You'll see it here moving. What that solenoid does is that operates the power split device. So this one motor, when it's turning one way, or when it's in one position, it will operate the loading gear, as you can see down here. If I turn it on, it should kick the tape back. Actually, it should unload. With my luck, it's broken. It should reset itself here. There it goes. Okay, so when the solenoid is in the closed position, and this solenoid is also used to engage the pinch roller, which is still sitting over here. When I push the tape in, the loading motor will, through the power split device, turn this toothed belt, which will operate the loading mechanism to drop the tape in. And then what you'll see happen is the solenoid here is going to release. The motor's going to come on again, and now the power, instead of it being sent to this outside gear here, because you see the teeth on the power split device here. In this position, it's going to lock this gear from turning, so this gear can't turn. So then the power is all going to go into this outer gear. The planet gears are in here, and the motor is actually turning the sun gear, which is in below. Once it loads, it's going to activate a switch over here. Actually, it's underneath here. There's a switch on the back here which tells the system to load, and there's another switch underneath here which gets activated. You can see it if I tip the machine up. See the little pin switches there? One of those pin switches is used to detect if the tab is broken, the record tab. The other pin switch is used to detect that the tape has been dropped. So when I insert the tape, what's going to happen is it's going to operate the motor, transfer power through the planetary power split device to operate the tooth belt to drop the tape, and once it detects that the tape is in, it is then going to thread the tape. If I want to simulate the tape threading without actually putting a tape in, it's very easy to do on these. All you gotta do is release the tape latch. This is what stops the mechanism from going in. Unlike the SL2500, which had all the switches, this one all you do is just push that down, push the tape in, and then activate the switch. And it will thread the tape, just like that. So on these ones, it's very simple. If you want to make sure that the mechanism's working, that's all you gotta do. And you'll see how the power split device works. So to activate, just press, and then press the inner switch. There's two switches, one here and one here. It's that one. The one on the edge is the one that detects whether the tape is missing its record tab or not. Anyway, so that's it's just getting kind of warm in here now. It's up to 10 degrees already. Heaters that make all that noise in the background are actually fairly efficient. So now the tape is threaded, and let's see what happens when I press play. I do not have a picture. Ooh, what is that noise? This is what I've got on the screen, incidentally. I've got it in freeze frame now, but I have a very bad picture. Oh, it just came on. Still doesn't look very good, but this is an old tape. Now, is this super beta or beta? Interesting. Well, it wasn't working, but it seems to have started working. Maybe the heads just were dirty. I just pressed the rewind key, but as you can see, that tape is clearly going forward. See, that's the rewind key. And it's going forward, as is the fast forward key. So this machine does indeed have a problem. Do you guys have an idea what this might be? Press play, press rewind, it's going forward. And I don't hear any sound either. I don't hear any sound on the tape whatsoever. How about...
Maybe it's something better.
Okay, so when it's in hi-fi mode, it's not playing any sound.
Expands.
This tape is recorded in hi-fi. Wonder why there's no sound. But anyway, that's If I switch to normal, where's the normal switch?
They had been stabbed.
I have sound on the normal track,
Systematically over a period
but I don't have any sound on the hi-fi track. So we have a hi-fi problem. But we've got this also, we've got this problem where when I press the rewind key over here, the tape goes forward. You can see the direction the tape is turning. That should be going backwards. It's not, it's going forward. Same with fast forward. Pay to skip forward, pay to skip backwards, it's going forward. So there's a problem with this. This could be an interesting one. Any ideas what it might be? I have a couple. That it could be. It could be a signaling problem. I guess the first thing to do is to take a look at how this unit is signaling the microprocessor to tell it what mode to go in. Is it a resistor ladder that's being used on this, or are they independent lines, like independent conductors? Because a resistive ladder would be probably a relatively early version, but let's pull the front faceplate off on this unit first and just examine that and see whether it's a resistor, like a voltage divider that is used. So I'm going to pull the bottom, or not the bottom, but a couple screws out of the bottom here. I want to take the front faceplate off and look at that. Actually, we can pull the bottom off this at the same time. I'm sure it's going to have to come off anyway, so let's pull the bottom off. So a servo board, and this is the AFM board, audio board on this one. The video board's on the top, and demodulator, FM mod. There's another board, by the way, in between here. It's sandwiched in between. Okay, now I should be able to pop this front off. Sort of. It does have the meters on the front here, which are connected. They're just plugged in with this one plug here. So undo that, get that out of the way. So this is the front, the FU38 board. Sony had a way with calling their boards unique things. It's almost like they were giving us the raised middle finger. The FU38. So let's just take a look at the FU38 board and take a look at how the buttons are configured. Are they going through resistors? Is it a ladder, or is it discrete signals that go? Now, one thing I could do is I could go grab a remote control and see whether it'll go into rewind from the remote control. That's one thing I could do. But what's weird here is if we look at the power light, when I just move the board ever so slightly, the power light's kind of winking at me. I wonder if I press rewind now, does it go into rewind? It's still going into fast forward. That's strange. It's almost like the board may have a crack in it somewhere, which is totally possible. I think I got all the screws out of this unit. The board should lift out. Okay. rewind switch is down here. I'm just going to jumper the rewind switch itself and see whether this goes into rewind or whether it still goes into fast forward. Because sometimes the switches themselves will fail and they'll pick up resistance. So I don't know which one I have to short. It's maybe these two together here. It's not even turning on. It's on, but it's not doing anything. It's very possible that this has to be grounded in order to work. We just put a ground wire in place. Okay, I've put a ground wire in place. Oh, look, now it's going into rewind. Well, isn't that strange? Is it possible that it was a bad ground on this screw here? Nope, it's not. But it did go into rewind that one time. You guys saw that, right? You saw it going in reverse. Now it's going forward again. If I remove the ground, it doesn't do anything. So it is a ground. There's a screw that goes through the board here that does ground it, and without that ground, it's not going to do anything. Trust Sony to ground through a chassis. But what I'm curious is it the switch? Is there resistance being built in the switch? So let's just see. Ah, it's going into rewind now. Stop. If I put my jumper from here to there, rewind. Interesting. I think I might have a bad switch. I press the switch itself, it goes into fast forward. See? Press the switch, watch the reel, fast forward. Jumper the switch, rewind. Cool. I have a bad switch. This unit is obviously using a resistor divider network to control the modes, and it looks like it's this resistor right here. If we look at the trace, that trace comes up to here. So the trace from here goes up to this jumper, and then it goes through that resistor. And that resistor is changing the resistance being sent to the system control IC, which is measuring the resistance and giving me an inaccurate read. So let's pull the switch out and see if we can fix it. This is one of the little heaters I'm using in here. The Heat Machine Plus, made in Canada. This was my dad's. He had this back in the I'm going to say it's into the early 80s. He used to use it. He had a motorhome, and he used to put this in there to winterize it so that it wouldn't freeze up, and it would keep the place toasty warm all winter. When I was working in the shop there, we got into a newer shop, and the guy that I worked for, he used to like to keep his store relatively cold. There was two HVAC units on the roof, HVAC and heating units. One that would heat the store and the storefront, and the other one would heat the stock room and the shop. And he used to keep the temperature turned down. Like, first of all, he never turned the air conditioning on in the summer. We'd bake, but he used to keep the temperature down at around, 64, 65 degrees in the stock room portion, which of course had the heat for the workshop when our workshop got moved to the back of the store, he used to keep it really cold, and I used to take this heater in there, and it used to piss him off because I'd run this thing, I'd have it sitting under my bench, I'd leave it running all day, and he'd get the electric bill, right? And the electric bill was higher, and he used to get mad, and he'd come in the back and he'd unplug the thing. Like if I got sent out on a pickup or a delivery, I'd leave the thing running under the bench because, you know, the shop was freezing cold. I used to keep it under my bench, and he'd show up and he'd unplug it, and he used to get so mad at leaving this thing run because it was costing him money, as he put it. I kept telling him to quit being such a cheap scrape and turn the heat on. He never would. So this thing had a lot of use over the years. Okay, this little switch is not one that comes apart easy, but we can still take it apart. I'm gonna have to pop the clip off here, and underneath this thing it's going to be a standard little button, and I bet it's all dirty and gungy, and we'll be able to clean that, I think. If I can get into this switch, which I should be able to pry my way into this, and we're going to have to put it back together and melt the plastic tabs over it again. But I should be able to get into this one. Or I could just try to find another switch. That's also an idea. I can also try to find another switch if I've got one. But we'll see whether I can get into this one and fix it. Because that's the whole name of the game. Let's fix things as opposed to replacing things. For you guys out there that might have one of these that's doing this. Okay, so the top's off the switch, and here's the button that you push, and it's got this little tiny little disc that, as you can see, has tarnished. That was normally silver in color, and if we look at the bottom, here's the bottom of the disc. You can see how tarnished that is. This is actually made out of like a silver, I think it's silver plated. But this is where our problem is. We have resistance building up on here. So I'm going to clean these contacts a bit. I'll just put a bit of deoxit on there, polish this up, put the switch pad together, and this should go into rewind. So I took my car out today, and this is probably the coldest that I've ever driven it, because it was like minus 10 today, which it never gets that cold here. So I drive an electric car. Now, you know, batteries don't perform very well in the cold. So when I turned it on, it said my range was down to like 25 kilometers. Normally it's around 50 on the older car. My newer one I'm not driving just because I don't have snow tires on it. I got snow tires on one of them. So I'm driving the older one. And as soon as I turned it on, it comes up and says, engine running due to temperature, because it's a plug-in hybrid. So I basically drove it on gas, which is nice because you get lots of heat off the engine, right? So the heat was blasting, and my battery is still full. It switched over and just ran off gas because it was so cold. I feel sorry for the guys that drive the Teslas and stuff that are fully electric, because when it gets cold like this, they lose a lot of range, and they lose even more because I got to run electric heaters when it's, you know, minus 10 or below. It's a little bit chilly out there today. You can see the dirt that's come off that right there. Same goes for inside the switch contacts here. Wipe them down. So I'll put a little bit more deoxit in here just to keep the contacts clean, and then we'll put the switch back together. And the button goes on top like this. My soldering iron just to melt the little tabs over to hold the switch together. So the switch works. Into the set, the board, and we'll be able to test it and see if it's working. Alright, we'll put the ground wire back on. See if it goes into rewind now when I press the rewind button. Okay, rewind. Ha ha ha. Now it's going to rewind. Excellent. Stop. Fast forward. Rewind. Fast forward. Play. Okay, that's problem one solved. Let's remount the board. The hi-fi audio problem might not actually be a problem. It might have been the person who recorded this tape had the audio level recorded turned all the way down to minimum, or they may have had the machine in simulcast mode, because believe it or not, people did that, and it happened more often than you would ever think possible. You know, I'd get VCRs in the early days of the hi-fi VCR. We would get lots of VCRs in, and the complaint was no sound. And we'd check the machine out, and well, we can't find anything wrong with it. And what we found was a lot of the cases on the machine, there's a switch on a lot of machines for recording from simulcast, and usually it's a switch on the front here. Input select. Is it a 3 or 2 position? It's a 3 position switch. Okay, that's more than likely what they've done on this switch. This switch, tuner, line PCM, and line audio. And I'll show you what it does, and I bet you that's what's happened with this tape, this tape that I've got here. This is not one of my tapes. This is a tape that came in one of these machines that was in the machine when I got it. More than likely, the dummies recorded it in line audio mode. I've plugged the front panel in right now just so you can see the audio meter. So if I show you the screen of the TV, I've just got CNN headline news playing here in the background, so I'll just kind of frame it like that so that you can see that there's a picture. But on this switch, if I flip the switch to the line input, okay, we lose the picture because we've switched to the line inputs on the back. But if I go over to the third position, you'll see that there's a picture, but there's no sound registering. If I switch my audio monitor over to mono, oh, there we go. There we go. That's the switch. It's yeah, it's this one. Normal. Okay.
I think he just thought.
In the hi-fi position, there's no sound because I'm in line audio, but the mono always records from the tuner.
18 years old.
Right.
Panicked.
And if I switch the other input back, right. So there's the hi-fi audio. There's the linear sound.
Picked up
This control is also dirty, so we're going to give this control a shot of cleaner before I put it together. I think that's the fault with why there's no sound recorded on this tape, is that the person who made the recording had the machine set to line audio, which was a simulcast mode, because you have to remember back in the day, in the early day when the Stereocast was first introduced, not every TV station was broadcasting in MTS. There was a number of stations that were still broadcasting in mono. And if they were running a concert, for example, they would play the soundtrack over a local FM radio station. And these machines had the ability that you could plug your FM tuner into the line input on the rear, and it would record the picture from TV, and it would record the line input from the stereo. In fact, I know people that would use these machines for recording audio. And they just record video that was on whatever channel. Because in the line input mode, when there was no picture present, like that mode there, even though you could use it as an audio recorder and there was no picture, I know of people that would use it as an audio recorder to record, for example, some of the FM stations at night would play a full album at midnight, and people would record the soundtrack onto a Beta Hi-Fi, and they'd just record whatever was on TV. If there was a movie or something on at the same time, they would record the picture, and then they could play it back. And well, I can get the audio that I've recorded off the radio, that cool new album that's running, or I could get the sound that goes with the picture. And they'd sacrifice the stereo sound for the TV program and use the stereo sound just for the radio. And I've got some tapes that are like that I recorded, but I did it differently. I had tapes recorded on my high 8 camera, and I went back and I dubbed in the PCM digital sound when I was many years ago, when I went down to I think I went down to Disneyland, back in the Disneyland and SeaWorld and stuff back in the I'm going to say the mid 90s. And anyway, I had my CCD V5000 camera that I was doing my recordings on, my scenery stuff and everything I was seeing. There was my wife at the time, and there was a cool radio station called The Wave in Southern California, and they played. It was a jazz station, what would become smooth jazz, but it was kind of a new agey jazz channel that we didn't have. I'd never heard anything like that back home. There was no stations that played anything like that. And I remember sitting in my car at my motel, unplugged the preamp outputs from my amplifier, and I had them plugged into my camera because I'd already made tapes. I'd already recorded all the video. So I had the video and the sound, and I went back and I recorded and I dubbed sound from this radio station onto the tapes and made these tapes and brought them home, recordings from The Wave. And I've still got these high 8 tapes that have got music recorded in the PCM track. I was going to give this control a shot of cleaner.
Was with a glass company. He worked with Whitfield,
That's a little better.
on this company.
You would see ads, paper, stove through the living window, rope, windshield, and access.
Okay, now we can make a recording. I'm going to put the faceplate on, put the front panel on. We'll make a recording on this machine. I'll clean the heads, of course, before doing that. We'll make a recording, play it back. I think this machine is probably okay, other than that rewind switch and the level control. Controls all the way down at minimum, as is the front panel control. It should just snap on. There we go. Like this one also used this one I think also had a Varactor tuner, if I'm not mistaken. You only had so many positions that you could set, if I'm not mistaken. You had like 14 positions. Yeah. So basically these old units, you could set 14 channels and only 14 channels. So like right now, this one has channel 3, channel 5, channel 6, 9, 17, 12, 13, 17, 19, 28, 29, 30, 31, 32, and then back to 3. You had 14 positions. If you notice, it just jumps, and that's just not because someone skipped it. You see that they're back all over the place. 3, 5, 6, 9, 17, 12, 13, 17, 19, 28, 29, 30, 31, 32. There's only 14 positions, and how you set this one up is you put it into set mode, and then it would show you which position. This is position number 2. Position number 1 was set to channel 32. So say I want to set position number 1 to channel 4 because that's the first channel on my little in-house cable system. So I would set the channel number first of all, so I could set it down to channel 4, and then I could use the tuning dial, and it would go through the stations one at a time. And I'll show you guys what's showing up on the screen as I do this. So I gotta find my stations here. What is that? What's the first one there? That's 5. I think that's 4 there. Why is 4 not running? Is 4 off the air? I wonder. Let me check it. Okay, I figured it out. My Raspberry Pi had crashed. So this is channel 4. And then I go here and I can change the channel number so it says 4. And then I hit the plus button to do the next one, which I want to make channel 5. So there's channel 5. And I can change the number so it displays 5. I press the next button, and the next one I want to tune is channel 7. So I just hold down the button until I get to channel 7, which will be another little media player thing. Oh, that's channel 17. Let's go. Oh, that's midband. That's why. Midband is first. There's channel 7. So I rename that one channel 7. Go to the next one, which is slot number 4. Press the plus button. And it should go up to the next one up, which is channel 9. There we go, channel 9. We have snow. And then the next channel up will be channel 12. And there's channel 12. So we'll call that one channel 12. And that's all I've got. So the next one up, I can just hit the clear button to clear that out. Clear all the rest of them out because there's nothing there. And then go turn off the set. And now it should only show me channel 4, channel 5, channel 7, channel 9, channel 12. And if I wanted to put the time clock that's coming in on 17, I could dial that in on the spare. Anyway, that's my in-house system, my 5 channels that I modulate onto carrier for testing. We'll go back and we'll make a recording onto this beta tape. We're going to clean the heads first, so let's just remove the tape. We'll clean the heads, and then I'll do a recording on whatever this tape is. Let's get a piece of paper, hold it up against the head drum, and spin the head disc counterclockwise. We'll clean the audio control head as well. At the erase head. The erase head's over there on this one. Audio control is down here. Pinch rollers there. Full erase and the capstan. Alright, make a recording. I'll hit the record switch and we'll turn the sound up. We'll just let this record for a minute or so and play it back and make sure everything's working. Everything's good. That should finish off this quick demonstration of how to fix a Beta for the problem of the rewind switch, building up internal resistance and causing the function to be incorrect. And that can happen on any of the switches. It just so happens on this one it was the rewind that was putting it into fast forward. Anytime you have any of these switches that seem to be doing something that they are not supposed to do, obviously if it's not working at all, then the switch has got no connection. But in this case, resistance had built up on it, and because it's using a resistive ladder to measure the voltage drop, to determine what mode it's going to go in, get a bit of oxidation on the contacts, and now we don't have a good read for the proper resistor that's placed in line with the control line that's being read for voltage. Because essentially what they're doing is it's just multiple resistors grounding out multiple resistors, and it's causing a voltage drop, and it's measuring that voltage drop, and that's what's determining what mode it's going to go in. It was a way to be able to basically control everything with basically two wires, well, one wire. You had a reference voltage pulling through a pull-up resistor, pulling it to your reference, and each switch was grounded through a resistor, which would drop the voltage a specific amount. Okay, rewind this back to the 0 point here, and playback. Turn on the sound and make sure that we've got sound. There we go. And the picture looks great.
She is put immediately in intensive care. She has tubes everywhere.
So I'm going to shut this off because this one here, obviously, if I show too much of that, CNN will probably have a fit. Anyway, this machine's all done. So I hope you guys learned something about how these switches operate. See how we're rewinding? And these machines are pretty good, picture quality wise. They're pretty good. If I go over to the TV again, you'll see the beta scan. Beta scan forward. Beta scan back. They also had beta skip scan, so if I was in full fast forward, I could hold the fast forward key and like sample. And same with the rewind. If you're rewinding a tape, you could press the rewind key again and it would go into rewind scan, and then of course hit play, and it would go back into full playback. That's it. Thanks for watching. We'll catch you in the next one real soon. Bye for now.